Okay, where exactly we are? I've forgotten the place. Okay, I think we develop a step to develop a procurement strategy. Okay, yeah, I think it's where we are. So we are starting with a step to develop procurement strategy. The first one is, I think this is where we are. Am I right? Hello? Hello?
Hello, sir.
I'm asking, I'm sure this is where we are.
Um,
Most of you can't remember.
Hello, sir.
Yes,
I'm
Raymond.
not sure if you're
I
in
think this is a
the
physics
different
class.
class.
So
You say what?
I think this is a physics class rather we should be having.
This is physics class.
Yeah.
Yeah.
Hey, are you sure?
Yes, so I'm
Yes,
confused.
because
Engineering.
Hey,
we
this
are
is
engineering, electrical
this is
engineering
procurement
department.
class. Oh. This is level 300,
No, we are electrical engineering level 100.
level 100.
Yeah.
Oh, I
Yes,
see.
sir.
Hey, how come? Okay, sorry. Then let's. Hey, how come? Okay, let me see what I can.
So I think maybe they gave us a wrong zone.
But okay, let me check. Okay.
Hello, sir.
Hello?
Hello, sir.
Hello, sir. Oh,
Hello, sir.
yeah, I'm having a challenges.
Yes. We just realized the link is not for us. The class is not. I think we are having physics and the lecturer is Dr. Adeti.
Oh, no, no, no. This should be,
So I think
sorry.
we are at the wrong place.
Uh,
So we are sorry, sir. We are sorry, sir.
Hello, good morning.
Good morning, sir.
Is this a physics class?
Yes, please.
yes, sir.
Yes, sir.
How are we?
We are fine, sir.
All right, your colleagues.
They are coming, eh?
Please, sir. Yes, sir. They are coming because we are finding challenges like joining different
They will
class.
join us
That's why.
with
Yes.
We are struggling with the link, eh?
Yes, sir.
Can you see my slide?
No, sir. No, sir.
Can you see it now?
Yes, sir.
All right, so can we continue? I should give them some time.
Here you can continue.
Is that the position of the class? The others will not talk.
Also, you can continue.
All right, today we want to talk about vectors. Is anybody here who have not done vectors before? Yes, as we are studying physics, as part of your new program that you use physics principles in electrical and electronics. sometimes we need to work with physical quantities that have both numerical and directional properties. So quantities of this nature are vector quantities. So this morning, what you want to look at and at the end of the class, we are expecting to know the various coordinate systems, define the vector and the scalar quantities, describe some properties of vectors, define the component of vectors and unit vector. So, do you remember the coordinate systems? What are the coordinate systems we have? Anyone remember? What are the coordinate systems we have? Because this, I believe that is just a revision, something that we have done before, and we know what it is. And when I give you a vector to add, to subtract, you should be able to do that without difficulties. So today's class is a discussion. We should be able to speak out. Let's discuss what we know. You have the coordinate system. Which one do you remember? Oh, nobody remember anything?
Hello, sir.
Yes, Raymond.
So we have the Cartesian.
Yes, I have the Cartesians. And which one again? The Cartesian X and Y coordinates. And which one again that any other person remember? The coordinate system. We mostly use the Cartesian plane, the X and Y coordinate system. That's what we mostly use. You know the X and Y, so we're trying to find. So which one again? If you want to find the direction, the angles.
Unit
How do you
vectors.
call it? Is that?
The unit vectors.
The unit vectors. Okay. Unit vectors. You want to find the direction that you are moving. Where does it fall? Yes, we call it polar. 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 All right, so we know vectors. And you want to show, we normally use the arrow to show the direction of the vector. That the vector is moving from A to B. We put the arrow on the A to B. That shows that the arrowhead is on the B and the tail is on the A, which shows that the movement is taking place from A to B. You have to be specific, and the person reading must be able to understand which direction are you moving, because we know about vectors that they have a direction. Yes, even before that, what the difference between a vector quantity and a scalar quantity? What the difference between them? What the difference between a vector quantity and a scalar quantity? Yes.
Scalar quantity has only magnitude, and vector quantity has magnitude and direction.
You have magnitudes and direction. Oh, great. Any other simpler definition? Any other simpler form that you can put it? Any other person with a different opinion? Scalar and vector quantity. Let's get involved. Let's get the class interesting. The class that you enjoyed is the class that you participated in. But if you don't participate in the class, you ended up not to enjoy the class. A minute, please. All right. So vectors, if you see a vector, what do you see? If you see a scalar, what are the common things do you observe? You break it down into the simplest term. Like we said, is having a direction, the other one is not having a direction. What do you see? The first thing you see is that you see a value. And you see a unit. But that of a vector will be added at direction. So a value, a unit, and a direction that will give you that of a vector. In physics, any value that you have written, there must be a unit attached to it. And without a unit, everybody will give different meaning to that. So you must be able to attach the unit to whatever that you have written. So a vector will have a value, a unit, and a direction. But a scalar will have a value and a unit. So those are the things that you're able to see and able to identify the difference between the two. So now, we are going to do more of the vectors because in a real world physical situations, it involves direction. For you to move from your house to your workplace, you must move on a direction. You have to make a movement. You have to make a movement and you have to apply a force. So all these things are our daily life. So you need to have knowledge about vectors because it helps you to go about your duties safely. Yes, there will be rain. Where? From where? The plane took off to where? Direction. All those things are key. You need to understand vectors because we use them in our everyday life. So when you understand vectors, it helps work more easier for you. It helps your movements. It helps the force that you exerted. So mostly we talk about motion. So we are just trying to talk about where are you going? Where are you going? Where are you going? That's basically what we're talking about. We're talking about motion. Where are you going? And then we talk about the forces. Which way are you going? Which way are you going? Which way are you going? Force. So we must know the direction. All these things we do them, but the point is we don't realize it's that we are using vector in our movements. So this vector principle is basically to describe our life, how we live our life. That's what it means. So these are basic principles that you should know. That's why when you go to school, you study on vectors. But sometimes we don't realize the applications. It's day-to-day activity. Have you ever realized it before? Have you ever realized that as you from your house, you're moving out, you're using vector in your movement?
No, sir, I haven't thought
So
about it that way. We are now realizing it.
Oh, that is how it is. Vector, where? Where are you going? Which direction are you going? Just got up from your house. Where are you going? Which direction? You're using vector. So for you to get to exactly that you are going, you are using the Google map that will take you to where you are going. You know where you are going, which direction is it in the north, the south, the east, is it northeast? Where? You are using vector. So let's see how we can add these vectors and how we can subtract them, how you break them into components. The X and the Y as how do you do that? So that's what we want to talk about. Vectors, as I said earlier, we are familiar with it, but it's only that we are not conscious of how we use them. But clearly, it shows that we make good use of them in our daily life. Everything that we do is about using vectors. So when we are talking about the scalar products, when you want to know the temperature outside so that you know how to dress, it's only that in Ghana that we don't consider the temperature before dressing. Okay, so you consider the temperature before you dress.
So please, they said,
Before you leave your house, how you
yes,
dress, do you consider the temperature before you dress?
yes. When it's sunny, I thought of where to wear, so I will not be feeling heat. And when the weather is cold or this thing, that is where we try to apply long sleeves and others.
I thought that it's only outside that they always observe the temperature before they leave their house. So we do so in Ghana too. Eh?
Personally, yes.
Oh, okay. Ernest, do you also do that?
Yes, sir.
You
Yes,
consider
sir.
you consider the temperature for your dressing?
Yes, sir. I do that a lot.
Oh, really? Wow. Rafa, do you also do that?
Yes, sir, sometimes.
Oh, you
Sometimes even the
consider the
colors.
temperature? Eh. Oh,
Because
I thought
black
it's only
attracts more heat, so I wouldn't wear it kind of like that when it's scotch.
eh. Wow. I thought that it's only outside that before you leave your house, you have to check and see how cold the weather will be so that I guess the body won't something that will warm my body and those stuff. Wow, that's fine. So for you to do that, what you need is the degree, how high it's going to be, or how low it's going to be. The number and the units. That's all that you need to know. That's all that you need to know. So the temperature outside, for you to know it before you know how you dress, what you need is the value and the units. What's the number? Is it 25 degrees or is 50 Fahrenheit? The number or the value and the unit. That is all that you need. So if you need only the number and the units, that's what we call the scalar quantity. You require to know the number or the value and the unit. That's what we call the scalar quantity. You don't need to know the direction before the temperature. You don't need the direction for temperature. Which direction is going? No. If the sun is shining, it's spread across. So you don't need to know the direction. Which direction will be more warm than the other? That's it, okay? Do you need to know the direction of the temperature? Do you need to know
No,
the direction of the temperature?
no, sir. No, sir.
No, sir.
Oh, but when you are in your room, you are putting on the AC. But some people who are directed, the AC directly on them, don't they feel more cold than the one at the other side? So would the direction be a factor?
Yes, sir.
Yes, sir. Yes, sir.
You see, we are talking about temperature. Temperature is mostly a surface activity, so you can easily get the temperature. It's just like you are taking a cup of a hot water and a bucket of a hot water. Which one will have the highest temperature? A cup of hot water, a bucket of hot water. Which one will have the highest temperature?
So I think the bucket of hot water.
Yes. Any other opinion?
I think we can only know the temperature if we measure.
Again?
I think you can only know the temperature if we measure.
No, I didn't get your point.
I was saying I think we can only know the temperature if we measure.
If we measure, yes, but how your expectation, what should it be? Should it be the same or one will be more than the other?
Okay, are they from one source?
You fetch hot water. Hot water is hot water. One in a cup and one in a bucket. The temperature, would they be the same?
I would say so.
All right. How about the others? I'm listening. Everybody should speak. Speak your mind. You can't be in class without talking. Get involved. Yes. What is your opinion?
So I think is the one in the bucket. Because if the water is more, I think the temperature will be more.
Okay. Who else? If you are going to talk, you unmute yourself. When you are done, you mute yourself so that the background will not disturb us. Yes, who else? Yes, sometimes I differentiate between what you call heat and temperature. But sometimes we miss the two, that heat and temperature, they are the same, but they are not the same. But let's say the example that I just gave you, the heat in the buckets depend on the number of molecules, so it will be more. But the temperature, surface something, put your thermometer in the hot water and put it, the bucket and the cup, the temperature will be the same. The temperature will be the same, but the heats will differ because the heats depend on the number of molecules or the size that you have. So the heat level will be high in the buckets. That's thermodynamics. That's the law of thermodynamics. But the temperature that we are talking about will be the same. It will be the same. That is what we are trying to explain. Temperature has only the value, the number, and the units has no direction. That's why we classify temperature as a scalar quantity because it has a value and unit without direction. So we need only arithmetic addition. We just need only addition to get temperature. Only addition. Just add the values. Just a simple addition. Simple addition to be able to manipulate. Just simple addition. That's all that we need. when it comes to scalar quantity, just simple additions. So let's look at this instance. If you are preparing to pilot a small plane, is anybody who had a dream to become a pilot when you were young? Is anybody here who were having a dream when you were young that you want to become a pilot? Hey, the class is quiet. Yes or no, if you cannot say.
No, sir.
No, sir. No, sir.
But why were you quiet? I'm talking to you. Make the class interesting.
Sorry, we're hoping somebody had that dream.
If you are preparing to pilot a small plane and need to know the wind velocity, you must know both the speeds of the wind and its direction. For you to fly a plane, you have to know the speed of the wind and the direction, because wind always blow to a certain direction. So when the wind is blowing, it blows to a certain direction. But all will not move at the same speed. So depend on the timing when it's about rain. So how the wind will be forcefully pulling down your plantains and your banana trees. Strong one. And it's moving in a particular direction. So if you want to know the velocity, you need to know the speed and the direction. So this tells you that when we're talking about velocity, it's having the units, the value, the units, and the direction. Is it moving towards the north, the south, the east? So that tells you that it's having a direction. That's what we're talking about. It's moving a direction to a particular direction. It's not just standing, but it's moving to a particular direction. That's why we say velocity is a vector quantity, because it's having the value, the units, and the direction. The direction is, where is it moving to? Is it going to the north? Is it going to the south? Is it moving to the east? That's the direction. So you need to know the direction to complete your arguments, your decision making. You are a fisherman, want to go to the sea. You should know about the velocity, the winds, and the comes, in which direction is it going, so that your sail can be adjusted accordingly. So basically, you can see the difference between a scalar and a vector quantity. Is that okay? Have you gotten the points?
Yes, sir.
I just want you to get it that when they mention the name of something, you just know what it is. So you analyze it based on this. Is it having a direction? Because when I talk about velocity of a wind, velocity, you cannot talk about velocity without talking about the speed and the direction. See, velocity. At what speed and to where? The motion. to where the force involved, to where the force in it, the motion and the force. That's why I wanted to analyze the two. So basically, scalar quantity and vector quantity, there should be a difference. So vector quantity, we normally use geometry mathematics for vector quantities. But for scalar quantities, we just do arithmetic additions. So 1 plus 1 is 2. It's a scalar quantity. So 5 kg plus 2, 3 kg will give you 8 kg. So the value and the units, use your calculator, you get it. The value and the units. That is a scalar quantity. Temperature is a scalar quantity. But the direction of your car, where direction is the car going, is a vector quantity. The velocity is a vector quantity. So that's what we are talking about. So vector is what we use the geometric mathematics. So you can use the Pythagorean theory and all those stuff to find. So this is what we talk about, directions. Last time we were talking about displacement and distance. And then we were talking about a basketball player move from one end and back. What's the distance and what's the displacement? You are playing a basketball. You have the basket on both sides. So you move from one and basket the ball and came back to the same point. The distance and the displacement. What is the distance and the displacement of that movement? What is the distance and the displacement of that movement? I think last time we were talking about something like that sort.
Yes, sir. Yes, sir. So
Yes.
the total distance is, assuming from one end to the other end is x, it's going to be 2x. And the displacement is the final minus the initial. And since it started from one point, went to the other side and came back, it's going to be 0 because he landed at the same place. So displacement is 0 and the distance is twice the pitch.
Oh, excellent explanation. That is great. That's how I always want my student to be. Yes, that's excellent explanation. You should be able to get this, and you don't miss it at anywhere. You should be able to get it, let it be part of you. Learning should be life. You should learn for life, not for exam. Don't learn for exam. Learn for life. Apply it. That's what it's supposed to be. It's a simple rules. Simple rules. Final minus the initial. We'll give you what? From the same point and back. We'll give you 0. But when you go and come back, it's twice the distance. It's twice the distance. Simple explanation. Thank you. So vectors, as we know how we use the alphabet, that we use the boldface, and we put the arrow on it. And I think we are familiar with this system of writing vectors. We are familiar with the vectors and how to find the magnitude of your vector. And magnitude of a vector is always positive. It's always positive. Can somebody demonstrate that? Why the magnitude of a vector is always positive? Can somebody demonstrate that why the magnitude of a vector is always positive? So the question will be, how do you find the magnitude of a vector? If you know how to find it, you know whether it will always be positive or it will always be negative. How do you find the magnitude of a vector? I've given you 3 and 4. 3 for the x, 4 for the y. Find the magnitude. Do that for me and give me the answer. 3 and 4. Find the magnitude. X is 3, y is 4. Find the magnitude. Who is done?
Hello, sir.
What's the answer?
So, 5 or is it 5?
You have gotten 5.
Yes, sir. I use the square root, then the sum of the squares. I don't know if that's the formula.
You have forgotten your vectors, eh?
A little, sir.
You apply it in everyday life, but it's not something that you forget, but it's only that you are not aware of it. All right, so use the 3 to be minus and the 4 to be positive, and let's see what you get. I think that formula is the same, it's accurate. So use minus 3 and 4. Let's see what you get.
Yes, it's still 5.
All right, let's use minus 3 and minus 4 and see what you get.
Still 5.
Why?
Because squaring minus makes it a positive number.
Great. That is true. You are scoring it. So always, there can't be any instance that you find the magnitude of any vector that will give you negative value, because you are going to square it. A square of every bar will give you positive. If it's positive, you square it positive. If it's negative, you square it, become positive. So a magnitude of a vector is always positive number. So if you know your formula, you will agree straight. Because when you test it, put it to test, you get positive values. That's what we have. Magnitude of a vector is always positive. All right, so let's look at this quick one. Your age. So write it down. When I call you, you tell me which ones are vector quantity and which ones are scalar quantity. Just write what you know. Write it down. Or better put, go to the chart column. Go to the chart column. Write the first one. vector and write your what's the element here, which ones are vectors, and write a scalar and write the scalar also under it. So go to the chart column and write them. No, don't send them, just write it and don't send. Just write it there and stop. Don't send, just write. Just write what you want, what you can differentiate them. Vector quantity, scalar quantity. Write it in the chat box, but don't send it. Write it. When you write, don't send. Just write. I'll use it as attendance, those who have come from my class. Is the lady here?
Yes, please, I'm here.
Hey, Yaira. You have been missing my class.
No, I'm here. It's just that I've been following, but sometimes I'm also lacking behind with the calculations. So I'll just keep quietly.
You are the only lady in the class, and then you are not adding anything to the class.
Oh,
Yaira, why do you behave like that? You are the only lady in the class. You should be able to lead the class, make the class interesting. And you don't even come. Maybe when you come, so we don't even hear your voice. Yaira. No, know that you are among guys. You have to behave appropriately. Get involved in the class. I don't like the door class. Class must be involved. Everybody in the class must get involved. You can't come and sit down in my class. Yes? Are we done?
No, sir. No, sir. You are still writing it.
Finish that. This is just write it, the scalar quantity, the vector quantity. Just write it. Just
So
write
please,
what you know.
are we
Just
writing
write
it
what
for
you know.
all of them or just the age?
No, write for all of them. All of them, they select them, group
Okay.
them. These are vector quantities. These are scalar quantities. Group all of them.
Okay, thank you.
Group them. Yes, it should be done by now. This is not calculation. No. This is not just say what you understand. Just write what you know. That's all. After that, we do it together. That's all. NS, are you done? Yaira, are you done?
Almost true. The typing
yes,
is a
please, I'm done.
Okay. Don't send, just write it. The message column, don't send. Just write it there.
I can't find one.
If you are done, let me know.
Yeah, that's sir.
All right, Alex is done. Who else? Oh, so far only Alex, that is done. Yaira,
Please, I'm done.
are you using your phone?
No, I'm using the laptop.
Yes. You have your laptop, you couldn't type those in quickly. Ernest, are you done?
Yes, sir, I'm done. But I went back to the message went away, so I have to type again.
I haven't asked you to send it. I just asked you to finish writing. I haven't asked you to send it. I just asked you to write. Just follow instruction. That's what makes you a good student. Don't set your own question and answer your own way. I'm the one setting the question so that I can mark you. All right, so I guess everybody is done. So now let's all of us send our answer. Just send it. Everybody should send at the same time.
Hey,
Done, sir. We are done.
Yes, everybody
I
should
wrote
send.
mine in my note. Wow.
I didn't get your question. I received from Bernard, Raffle, Emmanuel, Philip, Raymond, Alex, Yaira. Yaira, why? We have written only one, vector quantity.
Yes, because I wrote it down in my notebook, not in the chat box.
Yaira. And next. All right, so these are the students that I have. Yaira, and next. Alex, Raymond, Philip, Emmanuel, Rafael, Bernard. So I have only 7 students out of 14. Kingsley, how many are we in the class? The total student will be what?
It means we are 12 and you are 1, so making 13.
Is that?
Looking at the total number here, we are 12, which means that we are 11 students and then you
No. What I want to know is that how many students for the physics class? How many students are supposed to come for the physics class?
I think we are 17.
Is it 14?
No, we are more than that.
I think all of us, we have to come. Well, I don't know the reason why.
It should be how many? It said it should be how many?
So we are like 14 in number.
And that is what I know. But I want to be sure of the number. Yeah, we should be around 14 in number. But mostly, we're just about half of the class. So here you realize that we are only 7. I use this to take attendance. So next time we'll use questions to take my attendance. Because you cannot choose not to come to class and you come and write exam. It's not done like that. If you don't come to class, you will not write my exam. If you miss my class more than 3 times, if you miss my class more than 3 times, you will write my exam. And when you miss 1, you lose 2 marks out of the 10 marks for attendance. When you miss 2, you lose 4 marks. 3, 6 marks. Anything more than 3, you will write my paper. You will come back and write it. Because you cannot register for a course and you will not attend the class. How do you write the exam? What do you register? If you know that you are not free, what do you register for the course? I have not forced you to come. You paid for it. Why should you not come? What excuse do you have? All right, so let's move. So basically, we have only 3. That is a vector quantity. Velocity, displacement, and acceleration. Those are the only 3. They are the vector quantity, but the rest are scalar. The rest are scalar because they don't need direction. The displacement, where are you heading to? Velocity, you are talking about speed and direction. But the speed itself is a scalar quantity. The speed itself is a scalar quantity. The wind is blowing, but it's going to a certain direction. But the speed is having a speed. So the speed itself is a scalar quantity, but velocity is having 2 in 1. The speed and the direction, displacement and acceleration. These are vector quantities. All right. Coordinate system. So you have the Cartesian coordinate system, as Ernest mentioned earlier. You have the X and Y that intersects at the origin. We normally call the 0. So as we all know of it, you have the Cartesian plane. You have the X and Y axis that cross. So with this Cartesian plane that we talk about, the main thing we're talking about is the trigonometry. What are the quantities in trigonometry? Trigonometry, what are the quantities in trigonometry? Do you remember your trigonometry?
Please, are you talking about the 90 degrees, the 180, or you're talking about the cos, tan, and sine?
I didn't get you.
I was asking you that. Did you were you asking about the cos, tan, and then the sine tangent areas, or you're asking about the 90 degrees, the 80 degrees, the 260 degrees, or the 180 degrees? Please, what exactly did you want to know?
Yeah, the quantity, those are the tan, sine, and cos.
Okay.
Yes. Yes.
Uh,
Zaka.
the,
Yeah.
yeah, the quantities are, we have the core ratios,
Okay.
then the reciprocal quantities.
Okay. So now we have the quadrants. How do we name the quadrants here? Which one is the first quadrant, second quadrant, third, and the fourth quadrant? So you see my cursor. Which quadrant is this?
If we are doing it cast, then that one is going to be the adjacent.
No, which quadrant is this?
This is the first quadrant.
That's the first quadrant, sir.
Yes, this is the first quadrant. So the first quadrant, which of the quantities is positive here?
The x
All the quantities.
All the
All of
quantities
them.
are positive.
all the quantities are positive.
Yeah,
Great. So this quadrant is which quadrant?
3 and 3.
The x and the y.
This is the fourth.
The fourth quadrant.
That's the fourth quadrant.
This is the fourth.
Yeah.
Yes, sir.
Yes, please.
Yes.
So which one is positive here?
Cos.
The x-axis is positive, then I think the y-axis is negative.
Cos. Cos is positive.
Cost.
Yeah.
Yes, sir.
So which quadrant is this?
The third quadrant.
This one is what?
The
Third,
third quadrant.
So which of the quantities is positive here?
tan.
None of them is positive.
Is what? So which quadrant is this?
So the fifth quadrant.
Is there?
That's the second quadrant.
So which quantity is positive here?
Sine. Only sine is positive.
We call something casts. You heard of that before? You heard of the casts
No, sir.
Yes,
No, sir.
that they normally use for the quadrants.
We know of the cast.
So what is the C? Here is what?
CA. I think where your cursor is the A.
And then here is what?
The C.
And here is what?
T.
And here is what?
S.
Yes. Any other opinion?
Please, the where your cursor was, the third quadrant is the T.
Okay. Yeah.
The second quadrant is the sign, the S. And then
And
that's the
here.
cosine. The cosine. And then the fourth one, the fourth quadrant is also cosine.
All right. I think now I'm seeing Yaira getting involved. I like it. I want everybody to get involved. I love people talking in my class. If you don't like talking in my class, my distribution of marks is attendance and contribution is 10 marks. So attendance and contribution is 10 marks. That's my allocation of the marks. All right, so let's look. We call casts. Only I'm talking about casts. Here is the A, which stands for all. The A stands for all. A stands for all. So the cast, the C will start from here. The cast, so here will be the S and here will be the T. That's what we use to determine which one is positive at where. So when you write the casts from here, the A is the reference point for all of them. So when you mention the word casts, know that the A will be here. So that means your C will be here, and your S will be here, and your T will be here. So where you see then the alphabet, that is the one that is positive. So when I say cast, C is here, that means the cos is positive here. Casts, here is S. It means sine is positive here. Tan, T, tan is positive here. That's what it means. Casts, cos is positive here. All, tan, cos, and sine, they are all positive here. And only sine that is positive here. And only tan that is positive here. Take note of this because you are going to use it in your calculations. Depending on the quadrants, that will tell you which one is positive and which one is negative. Yes, so the second coordinate is what we call the polar coordinate system. This one you deal with basically direction. The direction. So the R is the distance from the origin, and the theta is the angle with the x-axis. And take notes, it always measures from anti-clockwise direction or counter-clockwise direction. So you know how the clock will move. The clock moves from your left to your right. Ta, ka, ta. So that means when you're going to measure coordinates, you measure from your right to your left. So you start from the S-axis. The S-axis is the mark line. So you start from the S-axis on your right and you go to your left. That's how you're going to measure. You come to polar coordinate system. You move from your right to your left, your right to your left. That's how you're going to measure it. That's counterclockwise or anti-clockwise direction, but the direction is from the x-axis. Take note of that. Polar system. So when you talk about the polar, this is what you are talking about. See where your R is from the center to the points. That's the R, and the angle that it made with the x-axis. So this is your x-axis, and this is your y-axis. So this is the 90. So this is the 0, 0. So these are the 0, 0 that you have here. So your 0, 0 that you have here. So this is your 0. So you are moving from here. This is your direction. This is the polar coordinate system. So take note of this so that when you are starting, this is the starting point. You don't start from here. And the angle, you make the angle that it makes with the x-axis, but not with the y-axis. It's not here. You don't create this one, but you take this one as the angle. The theta is here. So you can subtract this one from this to get this one, but this is not what we are looking for. We are looking for the one it makes with the x-axis. So take note of that when you're calculating the angle with the x-axis, not with the y. All right. Okay. So you change from Cartesian to polar, and you can change from polar to Cartesian plane. So the Cartesian is your x-axis is always cos. You use the cos. If you are finding something on the x-axis, you use cos. If you're finding something on the y-axis, you use sine. You use sine, the distance and the angle. The r is the distance, the theta is the angle. So if it's on the x-axis, you use cos. But if it is on the y-axis, you're using sine for it. So you can convert this, the x and y component, to a polar, to an angle. So that's what we use, the acute angle, that's what we use. So this one, you're using tan. Tan is what? Opposite over adjacent. Great. So your y is your opposite. The x will be the adjacent. So this is what you use to convert it to the polar form. The angle. So able to find your angle. So this is what we are using. You either use the Cartesian, they give you the Cartesian, you change it to a polar, or you have a polar, you change it to a Cartesian. This is how the conversion is going to be like. This is how you go about your conversions. All right, so it will be more clearer in the next slide. So it's the same thing on the next slide. So let me show you that one, okay? Are you there? All right. So this is the x axis, we use the cos. The y axis, we use the sine. So this is the angle. And this is your x axis. And this is your y axis. And your hypotenuse is the distance or the radius. So now this is the acute angle that it's making. So if you're finding the tan, is the opposite. Opposite is the y. The opposite to this angle is the y. The adjacent, where it's seated, is the x. That's why we are using the tan, y over the x. That's why we are finding this. The angle here is tan y over x. So if you want to find the radius and go back, you use this one. You find the magnitude to find your r. This is what we are going to do. Depending on the nature of the question, you should be able to do this. Yes, any question again? Ira, are you talking?
No, please.
Okay. Have you gotten the concept now?
Yes, please.
Okay. So we are going to do something right now. We have X value to be minus 3.5. Write it down. X is 3.5 minus 3.5. And the Y is minus 2.5. Y is minus 2.5. S is minus 3.5. Y is minus 2.5. Convert this one to the polar. So find your R and your theta. Let's see. So the X and Y is given to you. So find your polar, which means find the theta and find the
Sir.
radius R.
Hello, sir.
Yes,
Hello, sir.
I'm hearing
Please,
you.
the
Can you
Y value again. My network is not favoring me, so please the Y value again.
Y value is minus 2.5
And the X.
minus 3.5.
Okay.
So now find R and theta. Theta and R.
Okay, so please should we write it?
No, you can mention your value.
Because I'm getting a square root of 18.5. Oh, come on.
Do you have a calculator?
I left it at work. That's the thing.
When you're coming to my class, bring your calculator, get your calculator, because you're coming to physics class. You're going to do calculations. Get your jotter and your calculator. Don't just use only your phone for everything. No. Today is Saturday. If you don't have laptop, you can borrow a laptop from a friend just to use for the class so that you have more space for you to enjoy the class. It's a weekend, so you can borrow a laptop if you don't have, unless you don't have a good friend. Make good friends. If you don't have good friends, you struggle. If you don't have, you can borrow. I always tell my student that you must have a friend that when there's emergency to raise 20,000, you should be able to raise 20,000 from your friend. But if you don't have friends that can raise 20,000, then you have a problem. Yaira, do you have friends that can raise 20,000? Why are you laughing?
It depends on what you're going to use the money for.
Yaira, you have emergency. Do you have friends who can raise 20,000?
I have a friend who can support.
I'm not talking about a friend, but friends who can raise 20,000. Or you have only one person who can raise that one for you.
Exactly. Apart from that, I have an emergency fund.
Kingsley,
Yes, sir.
do you have friends who can raise 20,000 for you?
Yes, sir.
Are you sure?
So I'm now building it. I'm now building it.
You. You must make friends. At least in emergency time, they can raise 20,000 for you. So take it as your guideline. Yeah, yeah. I'm not talking about just only one failure. If that one failure and everything is gone.
Hmm. 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 Hmm.
Always ask your friend if there's emergency right now. Do you have people that I can call that can support me? If the answer is no, start now.
Sir, please, can we be friends?
You're always welcome.
Okay, oh, thank you.
All right. So what are your answers?
4.3.
4.3?
Yeah.
Yeah, I got 4.3. I don't know.
Yes, me
Yes.
too.
Yeah,
I got 4.3.
4.3. Then the angle I got is 35.5.
85.5.
Yeah.
35.5.
35.5.
Yes,
Yeah.
please.
Oh, okay.
But I know that you are supposed to like do some
Hello,
subtractions
sir.
and
Yes,
My angle is 216 degrees.
that is true. How do you get it?
So I use the y and x, which is the tan theta equal to y over x, and getting the theta, I inverse the tan. So when I got the result for the y on x, I inverse the tan so that I'll get only the theta.
Okay. And I give you that one straight.
Yeah. So it became tan theta equal to tan inverse of the result for the y on x.
Oh, okay. The calculator able to give you straight. That's good.
Yeah, so
Actually,
I simplified. I simplified actually.
what you're supposed to do is that the values are minus 3.5 and minus 2.5. They
Yeah.
are negative values, so they will be in the third quadrant.
Yeah.
They are minus values, so they will be here.
Yeah.
So if they are here, and then you are going to find the one closer to the x-axis. So this angle is the theta that you found, which is 33.5. That 33.5 is here. This is the angle. This is the theta. So,
Okay.
but what you are looking for, it's moving from here to this side.
Yeah.
So then you have to add 180 to the 35. 35.5. That means 36. So you add 36 plus 180, you get 216.
Yeah.
This is the one that we have, because you are starting from here. So you
Yeah.
move from here to this side. So the value given to you, check the values. Are they minus values? Know where you put them. The x is negative here, y is negative here. So it will be here. So
Okay.
what you are finding is from here to the x-axis. So what you found is for this 35.5 is here.
Okay, sir.
You are moving, you are looking at the distance. So you move from here to this side, and we have to add it to 180.
Yeah.
Get the actual value. Is everybody following?
Yes, please.
Does it make sense to you?
Yes.
Yes, sir.
Hey, Jehoshaphat, you just joined, eh?
No, sir, I joined about 30 minutes ago.
Hey, you know what is 30 minutes? I took an exercise, you were not part of it, so you cannot tell me that it's 30 minutes. So look at it very well. The angle that you found, first, the values look at where they are located. If they are minus minus, here it will give you minus y and x. So you put them here, but here minus minus it will be here. So what you are finding is for this. But what happened from the beginning? This is where it's supposed to come from. So you must add it to the 180 to get here. That is the correct answer. Supposed to 216. How you get the 216 is what I'm explaining to you. So basically, for you to get your R, you square, you get your 4.3. So for you to find your theta, the change in the y over the x, you get this. Take the tan inverse of that. It will give you 35.5. But what you must know is that your distance is moving from right to left. You are moving from right to left. So that's the movement that you are making into the third quadrant. What's supposed to be? That is your answer. Are we together?
Yes, please. But please explain how you got. Re-explain how you got the 216.
Okay.
Mm,
This is the explanation. When
okay.
you want to move, you move from the x-axis here. You move like this, from right to left. So the value given to you, they are minus values. So you have to come to the third quadrant and put the diagram here. So when you put the diagram here, the angle that you are going to find is from the one that to the x-axis. So the 35.5 that you found is to this angle. But now, where are you moving from? You are moving from here to this side. How do you get here? You must add, here is 90, here is 90. So you must add the 180 to this place to make the movement from here to here. Yeah, are you okay?
So please, you added the 90 degrees to the 180 degrees.
I've added from here to here is 180. Here is 90. 90 is when you add 90 is 180.
180.
Plus here, which is 35.5.
Okay. Okay.
You are
Okay.
moving from here. Don't forget that you are moving from here is your 0. So when I move from here to this side, it's 90. To this side is 90. So this small angle is 35.5. So I add it to it. So all from here to here, the journey will be 216, a whole number. Are you okay?
Yes, please.
Sir,
All right.
sir, please, the R side. I thought you said it's 35.5.
No, that's not R. That's the theta.
The theta.
The R, when you find the R, is the 4.3. That is the R.
Okay.
The R is 4.3. But now you are
Yes.
finding the theta. So you take your value over this, you get this. When you get this one, when you find the tan inverse of this, it will give you 35.5. But when you know where your graph is supposed to be, this is where you're supposed to be. So if it is here, the theta that you are finding is for this one. So you must add the distance from here to this side to get it. Should be able to get that. All right, so vector. You see this arrow, they are all moving in the same direction. So we'll say they are equal. These vectors, they are equal vectors. They are in the same plane, they are moving in the same direction. We call them they are the same vectors. So A is equal to B. A is equal to B. They are the same vectors. We call something a scalar product. We are using a number to multiply everything. I'm using 2 to multiply 5. 5 and 3. X and Y component. So 2 multiplied by 5 and 3. So it gives me 15 and 6. So I'm using a scalar product of 3. So here, I'm using a scalar product of 5. Here is 1. So this one, when I multiply by 5 to give it this long, so A and B. So the scalar product here is 5. Because here is A. When I multiply A by 5, it gives me this long. So I'm using the 5 as a scalar product to magnify the A. But you see that they are moving in the same direction. But if it is a minus, that means they are moving in the opposite direction. That's the red one. So the scalar product is minus 1 over 3. So it will move in opposite direction. Minus means you are moving in opposite direction. A equal to minus B. It means the A is moving in opposite direction of the B. When there's a minus, they are moving in the opposite direction. I think that one we know. So if you want to draw you have your vector A, B, C, D. And then you want to draw a vector AB. You put the arrow to the tail of the B. So this, we are just using the tail and the B. This is something that we know already, how to draw a vector diagram. It's something that you know, and you draw the resultants. The A, B, and then you use the C to cross, so that will be your resultants. So we add the A, B, C, D. So that is a vector that we are using. So here, there's a law that we call the commutative law. What it means is that it doesn't depend on the arrangement. I can say A and B, I can say B and A. It will give me the same results. That means they are commutative. You can interchange them to give you the same results. I can say 2 times 3 will give me 6. So let me change it. 3 times 2 will give me 6. So they are commutative. No matter how you place them, they'll be the same results. So there are 2 involved. But the associative, we are talking about 3 elements. But these 3 elements, the A, when I add these 2 and add it to the A, should give me the same thing as when I add this, the first 2 and add it to this. So to give me the same thing. That's the condition that we're saying is associative. It's associative. So vectors can be commutative, associative law. These are things that they are familiar with. Everybody here is supposed to know about vectors. But what I'm trying to do is that to explain it a bit further for you to appreciate how you use them in your everyday life. How we use the vectors in everyday life. That's what we are trying to do. Yeah, you want to say something?
No, please.
Okay. So now we are subtracting. So for you to subtract, as I said earlier, when you say A minus B, it's the same as A, you're adding it to negative B. That's what it is. A, you're adding to negative B. So A minus B should give you 0. So that means this one can go here without any difficulties. So the angle, so this one we are trying to show that when you are subtracting, this is the red, it's negative. And this is the A. The negative line is the red, and this is the positive. So you add them, they cancel out. They cancel out. So we have this angle from here to here is 180 rotation. So we're able to rotate 180. So you are subtracting, you are, so now when you are trying to subtract this movement from here, so you are just adding the minus B to the A. So this is the red line and the B. So these are something that should be able to appreciate when we are using values. These are directions. These are vectors. So we are using directions. Which direction are you moving to? Where are you starting from? Where are you going? So look at this. The magnitude of two vectors, A and B. So we have the vectors. A is 12 units, B is 8 units. Which of the following pair of the number represent the largest and the smallest possible? Try it, let me see. The largest, this one is a general knowledge. You don't need to be taught, but let me see. Who will get me the answer? 2 minutes. Hey, let's move fast. We have 5 minutes more. Kaira, what's your answer? Which one is the largest? Which one is the smallest? How do you get the largest and the smaller? That means you are adding and subtracting. That's a simple mathematics. How do you get the largest? When you add, you get the largest. When you subtract, you get the smaller.
Okay, so for the 144 units and the 4 units. Hello.
Yes, I'm listening.
Okay, so to get the smallest magnitude is 144 minus 4, which will give
Okay.
us 140. And then for the largest magnitude, you are going to add the 4 to the 144, making 148. So with that one, the minimum magnitude is 140, and then the maximum is 148.
Okay. All right. Let's move. Our time is getting fast. So you have 12 and 8. So when I add 12 and 8, I get 20. So the minimum is when I subtract the 8 from 8, I'll get this. So you do it for the second one too. So that's what you need to get. Do it for the second one too. And then we have, if a vector B is added to A, which two of the following choice must be true for the resultant force to be equal to 0? So this one, you need to go over it, see. For the result to be 0, the vector A should be, so when I have this, so vector B should be equal to minus this. So that means when you're having both opposite direction, this is the opposite direction. When you're moving opposite direction, it gives you 0. So this one is moving in opposite direction to this. That's what will give you 0. The question is, which one that will give you 0? The resultant will give you 0. That's what the question asks. So what do you need? The two vectors must be equal, and they must point in opposite direction, and they must lie in the same line. That means they have to be parallel. So these are the conditions. When we put the conditions together, A, parallel in the same direction. No. Parallel in opposite direction. They are parallel in opposite direction. That is true. The same magnitude. That's true. So these are the two conditions that you need for that answer. I'll give you the slide that you can go through it and check and see what is happening. So you have a car travel 20 kilometers due north and then in the direction of 60 west, I show in the figure. Find the magnitude direction of the car. So this is what we have. They want you to find the magnitude and the direction of it. It's something that you must take your time and do it and see whether you get the same results. Don't just read it, work it out. Work it out. Don't just read, work it out. So I'll just take you through because of the time. You work it out because the answers are here. Try and write them. These are the cosine rules and those stuff that we have. So when you work them out, these are the possible answer that you are going to get. But take your calculator, work it out. Though they are here, but I expect you to use your calculator to get it done. Get it done. Get it done. If you get it done, you are good to go. You are good to go. I think the quadrants that you guys was talking about. Yes, see the casts. So this is your first quadrant. As guys were rightly said, that is the fourth quadrant. This is the third quadrant. I think you guys rightly said it, but we use the casts this way, just to be able to remember which one is positive at where. So this one will remind you of all the things that you have learned. You go over the unit vector, where you have a value that you add, and then you subtract. That's how we do it. So you will be given this equation. The A and the B is this. So you want to find the R and the direction. So you add the I component together and add the J component together, the S, the Y, and the X. So after that, you have your 1, S, and Y. So you can find the resultant of it, and you can find the tan inverse of that you get. And this one too is have the same issue. If you were to find the tan inverse, we give you 27. But the 27 is just the angle that it makes with the x-axis. So you have to move from here and come here. So simply this small angle out of the 360, you can subtract this 27 out of the 360 to get the actual distance. Because you are just finding this one to the x-axis. But you are starting from here to this side. So out of the whole 360, this is the only small angle that you are finding. So it's better to subtract this one from the 360 and then know the exact angle. So to 337, not the 27. So that's what you have to take note of. And don't forget, the value here is, the x is 4. It's positive 4, and the y is -2. So this is where it's supposed to be. So the 4 is positive. This is the x, and the -2 is the negative. So it falls in this angle. So when it's in this angle, you have to move from here and come here to meet the angle. So the value given to you will tell you which quadrant are you supposed to go and to do what. So anything that you are finding, you go to the x-axis, you find it to the x-axis. So pay attention to this, and then you'll be fine. I have spent additional 2 minutes. Thank you so much for today's class. I believe you have enjoyed the class.
Yes, very well.
Thank you, Yaira. I enjoy your participation. I want to see you always in my class. Enjoy your week.
You too.
All right.
Thanks,
Bye-bye.
sir. Bye.
Bye.